This section, welcome back, you guys, your favorite trig course. We're going to take a look at properties of trig functions. So we're going to look at think about the domain and range right now. And we'll actually get in a lot more into the domain and range when we do the visuals of these trig functions. So I'm going to kind of ask you to be patient on that, but we can get the domains from the unit circle. So if you notice, from the unit circle, like your cosines, your x values, right? Notice all your x values go from -1 to +1. They're all in between there, anywhere they're at. Doesn't matter where you take it at. If I take that x value, I know it's between -1 and 1. Your y values, on the other hand, go from a y value -1 up to a positive value of 1. Right? And your domain, that's just talking about the input. You can find like the sine of anything, right? We could rotate it as much as we want. Maybe we'll go around 2 times, right? This 2 times 2 pi plus 2 pi, 4 pi times around, right? Like this number could be anything. So there's no restrictions on our domain, but the outputs will always be between -1 and 1. For the cosine, no restrictions, the output -1 and 1, and so on. And so they're all listed there with the domain and range. And I'm going to get in a lot more into the tangent, cosecant, secant, cotangent when we get into the graphs of those. Okay, but I just want you to be aware with a table for now. Now, as far as even and odd properties, if you think back to what is an even function from your first pre-calc course, and hopefully you remember an even function has this property: f of -x equals f of x. For example, y equals x squared is your classic even function, because if you plug in a -x, like -2 or something, it spits out the same y value as 2 does. Right, so f of -x spits out the same value as f of x. Right, that's a property of an even function. And so the cosine and the secant are even functions, and we'll see those graphically again in a different section, but that's an even property. These are even functions. Okay, both of those. That one's even, this one's even. So the cosine and its reciprocal, the secant, are even. Odd functions behave a little differently. That's where f of -x equals -f of x. So you may be thinking about like x cubed as an odd function. If I was to graph x cubed, you have like -2 cubed is -8. 2 cubed is 8, right? So in other words, if I plug in -2, it spits out the opposite of when I plugged in 2. So -8, right? So it spits out the opposite. F of -x equals -f of x. So these are odd functions. The sine's an odd function, the tangent's a sine function. And again, we'll see those graphs later, and you'll be able to see how they are reflective about the x and y axis to be odd. Okay? All right, let's go into, let's use these properties though for now, just algebraically, to find the exact value of the cosine of -30 degrees. So first I want to kind of review, could I find the cosine of -30 on my unit circle? Sure, I could just rotate -30 degrees. I could find it on my unit circle, and it's this point on my unit circle. If I rotate down -30 degrees, the cosine would just be the x value there. So our answer is √3/2. But let's do it with our even odd properties instead. Cosine of -30 degrees. Well, cosine of -t is the cosine of t, right? That's what I'm using. Cosine of negative t is the same as the cosine of t because it's even. So this is the same thing as the cosine of 30 degrees, right? So cosine of negative 30 is the same as the cosine of 30. So we look on our unit circle. If I rotate 30 degrees, I find the point, I find the cosine there, and I'm like, oh, the cosine is root 3 over 2. Let's look at the next one. How about cosecant? Now this one's not with degrees. I got radians. Cosecant of negative pi fourths. Notice my cosecant. Cosecant is an odd function, right? Cosecant of negative t is negative cosecant of t. So this is odd. This is odd. Cosecant of negative t is negative cosecant of t, right? So cosecant of negative pi fourths is negative cosecant of pi fourths. Well, the cosecant is 1 over the sine. So we've got negative 1 over the sine of pi fourths. So now we can just go to our unit circle. We pull up our, or we look on our unit circle or construct our unit circle. We rotate pi fourths, which is 45 degrees. We find the point there and we say, oh, the sine is the y value. So this is negative 1 over root 2 over 2. Multiply by the reciprocal to simplify this. So we've got negative 2 over root 2. We do need to rationalize that. So we got negative 2 root 2 over the square root of 4, which is 2. Notice the 2's cancel. So this bugger just ends up being negative root 2. Now let's talk about some periodic properties for a minute. So this is saying the sine of t plus however many times around, full revolutions around, is the same as just the sine of t. So for example, let me go pi 6 plus 2 pi, which is the same thing as 13 pi sixths. Sine of 13 pi sixths is the same as this, pi 6 plus 2 pi, okay? So that's 1 full revolution plus pi 6 more, right? So I go around once, there's 2 pi, and pi 6 more, which is 30 degrees. So I'm right here. So the sine of 13 pi 6, which is around once 2 pi plus pi 6, is the exact same thing as the sine of pi sixths. They're at the same spot. If I just rotate pi 6, they're at the same spot on my unit circle. And so what would the sine be for pi 6? Just be a half. It'd be the y value there. Okay. So that's what the periodic properties are saying. So let's do another one here. Sine of 1485. So I'm like, oh gosh, that's more than 360 degrees. You know, how much more than 360 degrees? Well, I'm like, gosh, I could go around, what's 1485? Put my calculator here, minus 360. So that's the same as 1 time around plus 1125. But if you notice, I'm still more than 360. So let's go around again. So let's go 360 stays there plus another 360 because 1125 minus 360 is 765. Okay, so I've gone around twice, 360, 360, and 765. Well, 765 is still bigger than 360. So I got to keep going with this. So I got 360, got another 360, Now the 765 minus 360 gives me the 405. So, okay, 3 times around and 405. You guys kind of, at least this is kind of how I'm thinking about it if I'm going to do it kind of slow here. Well, 405 is still bigger than 360. So this is the sign of once, twice, 3 times, and a 4th time with a leftover of 45 degrees. So in other words, 4 times around and 45 degrees left over. 4 times around are 1440 degrees, right? So if I was to draw this, let's go up here and draw this thing. There's 1 time around, 2 times around, 3 times around, 4 times around, plus 45 degrees. I'm right here. Plus 45 degrees. So this is the same as the sine of 1485 is the exact same thing as the sine of 45 degrees. They're the same thing if I just did 45 degrees. So I find on my unit circle, I find that point, right? Or construct the point when you're constructing it on the test. And I say the sine is the y value. So root 2 over 2. And that's it. All right, guys, let's go tangent negative 17 pi 4. So what I'm going to do is I'm going to say, well, I know this is in radians. I know 2 pi is 1 time around, or in the negative direction, negative 2 pi, right? But this is in fourths. So in fourths, that'd be negative 8 pi over 4 is 1 time around. So this is the tangent of negative 8 pi over 4. That's 1 time around. 17 minus 8 gives me 9 pi 4. So I would still have this much left over. Still have that much left over, right? 9 pi over 4. That's still bigger than 8 pi over 4. So what I'm going to do is I'm going to go around once and again. There's negative 16 pi over 4. I need negative 17 pi over 4. Negative 8 minus 1. There's the negative 17 pi over 4. So I'm around twice, right? There's 2 of these negative 8 pi over 4s. 2 of these, I'll write it this way, 2 of these negative 2 pi's, that's negative 16 pi over 4, is negative 4 pi, with a leftover of minus pi fourths. So it's just the same as the tangent of negative pi fourths. So then I go to my unit circle, and I rotate negative pi fourths, or negative 45 degrees, negative pi fourths, or negative 45 degrees. I find my point, and I say, all right, the tangent of negative 17 pi over 4 is the same as the tangent of negative pi over 4, which is the sine of negative pi over 4 over the cosine of negative pi over 4. The sine is the y value there, negative root 2 over 2. The cosine is the x value. So it's like negative 1, right? It's like negative 3 over 3 type of deal, negative 1. And I should mention on this one, you can use your even-odd properties on this too if you'd like. You could do this a different way, but you'll arrive at the same place. You know, the tangent, since it's an odd, this is odd, so tangent of negative 17 pi fourths is actually negative tangent of 17 pi fourths. And then you'd go through the same process. Well, that's 2 pi plus 2 pi plus pi fourths. So twice around and pi fourths. And then you'd do it just on the positive pi fourths, but you'd have to put a negative in front. Well, the sine of pi fourths over the cosine of pi fourths Again, the negative stays there. Sine of pi force is positive root 2 over 2. Cosine pi force. And you see how it ends up still being the same thing, even if you use that property when you start it out. Okay. All right, let's keep going. Let's use some even odd properties here. I've got negative 2 sine of 3t plus 2 pi. Notice the 2 pi. That's one time around plus 3t. So this one simplifies to just negative 2 sine of 3t. Okay. And then the second one, remember the sine function is odd. So the sine of negative theta is negative sine of theta. So it's kind of like that negative can go out front. So it's minus a minus 3 sine of 3t. Because it's odd. The cosine's even. Cosine's even. Cosine of negative theta is just cosine theta. So cosine of negative 2t is the same as just the cosine of 2t. So we've got negative 2 sine 3t plus 3 sine of 3t plus cosine of 2t. And we just kind of cleaned it up with the properties that we have. Oh, I'm sorry, that's not quite done. I have like terms, my apologies. Both of these are sine of 3t's. So I have negative 2 plus 3 is a 1 sine of 3t. 1 sine of 3t. There we go. This next section with reference angles. These reference angles will really help us when we start finding sines, cosines, tangents of spots that are not on our unit circle. Okay, and so let's talk about what a reference angle is. A reference angle is an angle between 0 and 90 that is formed when you take the terminal side. So we rotate theta as usual. Here's theta. And you see how we end up right here on the, that's called our terminal side. This was our initial, this was the initial side. This is our terminal side where we end up after the rotation. The reference angle is, what you do is you take it from the terminal side and you can make a 90-degree angle. You go straight down to the x-axis, and it's that angle right there. I'm going to call it theta prime. It's the angle between the terminal side and the x-axis. Okay, so for the second one, it's rotating into quadrant 3. Here's our terminal side. I take it straight back, and theta prime is right in there. Theta prime's that angle right in there. Okay, so for example, if this rotation, let's say it was like, if theta was like 210 degrees, then I'd say, oh, well, theta prime, how much past 180 did I go? 210 minus 180 is 30 degrees, right? So theta prime here, that little red theta prime would be 30 degrees. That'd be our reference angle. In the first scenario, let's say theta was 100 degrees. Okay, so theta prime is, well, how much is left over? Well, if I went all the way halfway, it'd be 180 degrees. So theta prime would be 180 minus the 100. So theta prime in this picture is 80 degrees. Now let's do one into quadrant 4. So let's say we rotate, let's go 300 degrees. We'll just go 300 degrees. How about that? I'm going to take it from the terminal side. I'm going to go straight back to the x-axis. Theta prime, or the reference angle, is right in there. and I say, well, the whole way around is 360, so theta prime would be 360 degrees minus our original theta. So theta prime must be 60 degrees in there. That's how you find reference angles. Okay, so let's do it for this first one. Find the reference angle for 170 degrees. So let's go ahead and rotate 170 degrees. So I'm like, okay, I'm not quite 180, but I'm into quadrant 2. Here's my, oops, that's kind of a terrible drawing here. Here's my 170 degrees. Let me drop this straight down, and my theta prime will be right in there. And so how much would our theta prime be? You take that, theta prime would have to be halfway around 180 minus the 170. So in this case, the theta prime is just 10 degrees there. Yep. All right, let's do it with radians this time. 9 pi over 5. And you know, if you're not sure where this is, yeah, just convert it. Let's see, 180 divided by 5 gives you, is that 36? 36 times 9 is 324. So this is 324 degrees. Okay, so I'm going to draw that into, okay, here's 90, 180s halfway, 270s right there. So I got to go past that into the 324 degree range right there. So here's my 9 pi fifths. And by the way, another way to think about this is all the way around is 2 pi. In terms of fifths, 2 pi is the same as 10 pi fifths. So it's not quite 10 pi fifths. Right, not quite 10 pi fifths. Not quite all the way around. It's 9 pi fifths, right? Draw this straight back. Let's go ahead and find this reference angle I'm going to call theta prime. So if we were doing this in terms of degrees, we'd say, well, that's all the way around minus 324 degrees. But I don't want to go all the way around. I'm sorry, I don't want to do this in terms of degrees. I'm going to do this in terms of radians. So 2 pi minus 9 pi over 5. Get a common denominator here. So our theta prime is 10 pi over 5 minus 9 pi over 5. So our theta prime, 10 pi minus 9 pi is a 1 pi all over 5. So in other words, 36 degrees, right? 360 minus 324. All right, I'm going to make this a U-try-it problem. This is a good time. Go ahead and pause it and make sure you can draw 120 degrees and find the reference angle. So hopefully you drew this thing into quadrant 2 here. There's your theta being 120 degrees. And come straight back, draw your theta prime. So that theta prime's got to be halfway around 180. So it's just the 180 minus the 120. So theta prime equals 60 degrees, or same as pi thirds, right? 60 degrees pi thirds. So I'd like to have you do one more. Let's do this one in, keep it in radians. Do your best to keep this in radians if you can. So good time to pause it. Try this one as well. Yeah, you're right. Good, pi 6. Good, all right, so let's go through. Let's draw 11 pi 6. Now I know all the way around is 2 pi. In other words, 12 pi 6 is all the way around. 12 pi 6, which is all the way around. This is not quite there. This is 11 pi 6, right? So then the question is, what's the leftover theta prime? Well, theta prime would be 360 degrees minus 11 pi 6 is 330 degrees, as Aubrey mentioned. So in degrees, this is 30 degrees. Again, let's do this, though, in radians. 2 pi is once around minus all but 11 pi 6. So 12 pi 6 minus 11 pi 6 is just a 1 pi 6. So 30 degrees is that reference angle. Okay. All right, let's get into sine values, sine, cosine, and tangent in each quadrant. If you look at your unit circle, right, in quadrant 1, you take any x, y. Remember, x is our cosine, right? Y is our sine. Well, in quadrant 1, x and y are both positive, right? And so the tangent, which is sine over cosine, would also be positive, wouldn't it? Because it'd be a positive value over a positive value. That's why all of them are positive in quadrant 1. Now let's go to quadrant 2. Over here, now I've got a negative x and a positive y, right, in quadrant 2. So my cosine's negative, but my sine is positive. So when I go sine over cosine, positive over x, my tangent would then be negative. So who's the only positive one in quadrant 2? Just the sine. So how I remember this is all students, okay, all of them are positive in the first quadrant. Only the sine is positive in the second quadrant. Take, only the tangent's positive down there. Calculus. So only the cosine's positive in the fourth quadrant. But I just like to do it conceptually, personally. I just kind of think about it, and then it kind of helps me review it. But if you want to look at that, all students take calculus quadrants 1 through 4. That'll tell you who's positive and where and in which quadrant. So let's go ahead through this first one. Name the quadrant in which angle theta lies, given that the sine is less than 0. So in other words, the y value is negative, and the cosine value is positive. So if the cosine is positive, if my x is positive, I could be in either of these quadrants, right? If my x is positive, I got to have a positive x. You guys with me on that? Positive x would be in either of those two. So that'd be quadrant 1 or quadrant 4 would have a positive x. Now a negative y, where is y negative? Well, y's are negative down here, and y's would be negative in quadrant 3. So this is quadrant 3 or 4. Now they both have to occur. X has to be positive, but y's got to be negative. So the only option for our answer would be, oh, that's got to be in quadrant 4, right? So it's got to be in quadrant 4. And so I draw this into quadrant 4. That's where I have a positive x and a negative y. Again, positive x and a negative y, right? That's how you can think about that. So what's going on? All right, let's do this next one. Where is the tangent less than 0? So the tangent's got to be negative. Remember, the tangent's the sine over the cosine, right? And it's also got to satisfy, here, let me take it over here actually. And cosine is less than 0. So our x value is less than 0. I'm going to start with the x value. I know if my x is negative, I'm in either quadrant 2 or quadrant 3. Those are my options if the x is negative. Right? Well, if the tangent's negative, then I either have to have, and I know my cosine's negative, right? So I'm going to put a little negative down here. If the cosine's already negative, the sine would have to be positive, because a positive over a negative makes it a negative. So the sine This is saying the sign's got to be positive. Well, if the sign's positive, the y value is positive, then it's either in 1 or 2. So where do they both occur? Quadrant 2. That's our only option, is quadrant 2 for this. All right, let's keep going here and how to find the trig value for any angle. So what we're going to do is we're going to find, for example, on this first one, cosine of 135 degrees using the reference angles. Okay, using the reference angles. So what we'll do is, number one, we'll go ahead and draw it. Oops. Let's draw this thing. Okay, Andy, there we go, into quadrant 2. There's our theta being 135 degrees. Okay, number one. Cosine 135 degrees. Well, now I can go ahead and find, let's go ahead and find our reference angle here. So 180, number 2. The reference angle theta prime is just 180 minus 35. So the theta prime is 45 degrees, right? And I know on my, on my unit circle at 45 degrees, I'm root 2 over 2, negative root 2, I'm sorry, positive root 2 over 2. That's where 45 is. So 135 will just have a negative x. So this on the unit circle will be at negative x, positive y. But it'll have the same x and y. It's just your x will be negative, right? So now we could just apply the appropriate sign, if you will, the cosine of 135 degrees, which is the x value is negative root 2 over 2. Okay. All right, let's do it first. Sine of 4 pi thirds. Sine of 4 pi thirds. Sine of 4 pi thirds. Now, I know 3 pi over 3 is 1 pi. There's 1 pi halfway around. So I got to go pi thirds past that. So I'm into quadrant 3. Here's my theta being 4 pi thirds. In other words, that's 240 degrees, right? 240 degrees. So I'm going to draw it first. Number one, let's draw the thing. Number two, let's go ahead and find the reference angle on this. So theta prime in there. So theta prime would be 240, if you're doing it with degrees, 240 degrees, 4 pi thirds minus the 180. So in this case, it'd be 4 pi thirds minus pi if you can do this with radians. Yeah, put that over 1, get a common denominator. So it looks like 4 pi thirds minus pi thirds is a 1 pi third. So there, theta pi is pi thirds, or 60 degrees, right? So if you remember at 60 degrees on your unit circle, I find my unit circle, that's at 60 degrees. So this will just be a negative x, and a negative y. And so the sine of 4 pi thirds is the y value there, negative root 3 over 2. All right, this is a good U-try problem, you guys. So good time to pause it and work through it. So go ahead and draw that cosine, draw the 330 degrees and go through that process there. So hopefully, number one, you drew the 330 degrees, almost all the way around, not quite. There's the 330 degrees. So the reference angle here, theta prime, would be not quite all the way around, all but 330 degrees. So the reference angle in there would just be 30 degrees, right? 30 degrees. So if you remember on the unit circle at 30 degrees, you have the point square root of 3 over 2 comma half. So this will be square root of 3 over 2 positive x, but a negative y, negative a half, right? So we're finding the cosine here, which is the x value. So the x value is just square root of 3 over 2. If we were finding the sine of 330 degrees, then I'd say negative a half, right? All right, let's go ahead again. A good time to pause this next one and go into tangent of 14 pi over 3. So tangent, our theta here is 14 pi over 3. So if you're drawing that, notice this is more than 2 pi. You know, 2 pi one time around in terms of thirds is 6 pi thirds. This is 6 pi thirds plus another 6 pi thirds. There's 12 pi thirds. That's 12 pi thirds. But I need to get to 14 pi thirds, so 2 pi thirds more, right? So this is around twice and 2 pi thirds more, right? Around twice plus 2 pi thirds. So when you draw this, I'm around once, I'm around twice, and 2 pi thirds, by the way, if you're multiplying it by 180 over pi, 2 pi thirds is 120 degrees. So you're about right there. Draw that thing. There's theta being 14 pi thirds. It's the same spot, same terminal side as 2 pi thirds, right? So 2 pi thirds. Go straight down. Let's name our reference angle theta prime. So theta prime would be 180 degrees minus pi, right? It'd be 180 degrees minus 120 degrees, except we're doing this in radians. So pi minus 2 pi thirds. In other words, 3 pi thirds minus 2 pi thirds is 1 pi third, right? There's our theta prime, or 60 degrees, right? So if I'm thinking on my unit circle is 60 degrees, there's my spot, there's my cosine and my sine. So this will be negative x, positive y, because it's quadrant 2. So last step is to find the tangent of 14 pi thirds, which is the sine over the cosine, and our sine here is the y, the cosine is the x. Keep change flip, multiply by the reciprocal, in other words, when you're divided by a fraction, right? And so you got negative 2 root 3 over 2, 2's cancel. Looks like this is just negative root 3. Tangent negative 225. So let's draw that. There's negative 180. I got to go how much more? 45 more than that. Drop that down. Here's my theta prime. This theta is negative 225. So theta prime, in this case, would be 225 minus 180. So 45 degrees on that, right? And so instead of root 2 over 2, comma root 2 over 2, it's a negative root 2 over 2, positive root 2 over 2, right? And so the tangent of negative 225 would be the sine there over the cosine. The sine's the y, the cosine's the x. So you see how you got the same thing or the same thing, except the top is positive, the bottom's negative. So this just ends up being negative 1. Let's go for negative 210 now. So let's rotate negative 210. How much past 180 is it? 30 degrees past. So our theta prime, I'm 30 degrees past. So this is theta prime here is 30 degrees, right? Well, 30 degrees, I'm root 3 over 2 comma half. So in this case, I would be negative root 3 over 2 comma half for that 30 degree. And the secant is 1 over the cosine, and the cosine here is the x. So I got 1 over negative root 3 over 2, which again, flip that around, negative 2 over root 3, rationalize that, and you've got negative 2 root 3 over 3. Let's go with sine of negative 11 pi thirds. This is more than 2 pi, right? This would be around 1 time in the negative direction. There's negative 6 pi thirds. That's a negative 2 pi. I got to go 5 pi thirds more to get to negative 11 pi thirds. So here's around once. 5 pi thirds more, that's like negative 300 degrees more. So I end up right there. So that's negative 5 pi thirds is the same spot as negative 11 pi thirds. And so your reference angle, theta prime, your reference angle would be 2 pi minus that 5 pi thirds. So 6 pi thirds minus the 5 pi thirds, or pi thirds. Pi thirds, which is 60 degrees. So it's at 1/2 square root of 3 over 2. And so the sine would be the y value, the root 3 over 2. All right, let's do some more for one more reference angle. Cosecant negative 19 pi fourths. Cosecant, well, that negative 8 pi fourths, that's 1 time around, negative 2 pi. Negative 16 pi fourths, there's another time around, there's negative 16 pi fourths. I got to go 3 pi fourths more than that. All right, so I'm twice around negative direction and 3 pi fourths. So here's once around negative, twice around negative, 3 pi fourths, which is like 135 degrees, by the way, negative 135. That's right there. So negative 19 pi fourths is the same spot as negative 3 pi fourths. So the reference angle theta prime, right? Theta prime would be pi minus 3 pi fourths. So 4 pi fourths minus 3 pi fourths is just a pi fourths. Pi fourths, 45 degrees. So negative root 2 over 2, x is negative, y is negative here in quadrant 3. So the cosecant, is the same as 1 over the sine. And the sine here is the y value. Now we got to flip that over, 1 over that, right? Multiply by the reciprocal. Rationalize that. And we've got negative 2 root 2 over 2. 2's cancel. This just ends up being negative root 2. All right, let's see if we can put this together now. Let's say our tangent, so this is giving us a spot. This is not on the unit circle. This is what we're kind of building up to. They tell us the tangent's negative, the sine is negative, right? The y is negative, and notice here our tangent is also negative. Well, if the sine or the y is negative, here's where my y is negative. The tangent is negative, that means sine over cosine. I already know my sine is negative. Well, if the tangent's negative, that means the cosine's got to be positive. Well, the cosine's positive, the x is positive in 1 and, whoops. Oh gosh, guys, I marked these wrong. That's 3, this is 4. Sorry about that. In blue, there, 4. The cosine's positive, right? They would be positive x in 1 or 4. So where do they both occur? Right here in 4. So I'm going to draw this thing into quadrant 4 now. Let's draw this. Oops, make this a little bigger. Draw this theta into quadrant 4. So I get the proper location. And what we're doing is we're going to use right triangle trig to do this. And so we're going to use our reference angle theta prime and the information given. Okay. So here's our theta. So we're given tangent theta is negative 3 over 4. Remember, tangent, let me erase this other stuff here. Remember, tangent is, oh heck, another hour of algebra, SOHCAHTOA, of algebra, right? So they're giving us I'm going to label my triangle using theta prime, using the reference angle. So I'm using right triangle trig to do this. I know theta is bigger than 90. That's why I'm using the reference angle to kind of cheat the system a little bit, because I can use right triangle trig with only angles less than 90. So I'm going to label this tangent. I'm going to label the opposite side of theta negative 3 and the adjacent side of theta prime 4. Okay, and make sure that's positive x, negative y, right? Positive 4, negative 3. And then what I'm going to do, step 2, is I'm going to solve for the remaining side c. Remember, this is a right triangle. A squared plus b squared equals c squared. So I got negative 3 squared plus 4 squared equals c squared. 9 plus 16, I got 25 is c squared, square root. I got plus or minus 5, but this is a distance, so I'm going to name that 5. So let me erase c. Oops, let me erase c. Oh my gosh, I'm making a mess here. And let's put the 5 in that we just solved for, okay, our hypotenuse. Now I got a triangle labeled. Again, this is not on the unit circle. Can you see how my radius here is 5? Right, this is not on my unit circle. So this is how I have to approach this, is using my reference angle to do this, using my knowledge of right triangle trig. And now it says find the exact value of all 6 trig functions. Well, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent, we already know, is opposite over adjacent, but they gave us that one. And then we'll flip them all around, right? So let's do it. Sine opposite over hypotenuse. So that's the negative 3/5. Cosine adjacent over hypotenuse. Again, I'm using my reference angle theta prime here. So 4/5. We already have tangent. Now let's find the reciprocals. So the reciprocal of sine, cosecant. So negative 3 over 5, flip it over. Negative 5 over 3. Reciprocal of the cosine, secant. Flip that one over. Instead of 4/5, I got 5/4. Flip over the tangent. And instead of negative 3/4, I got negative 4/3. And here's all 6. Okay. Let's do another one here. Cosine in this case is negative 1/4. And they tell us, hey, this is it's less than 270, but it's greater than 180. So I got to rotate into quadrant 3. Okay. They tell me that thing's in quadrant 3 because I'm more than 180, but I'm less than 270 degrees. Let me draw my right triangle, drop that straight down, put my little theta prime in. The theta is the full rotation. The theta prime is that reference angle inside there, that acute angle less than 90 degrees. And I'm going to use this given information. Cosine, remember, cosine is adjacent over hypotenuse. So the adjacent side, so I'm looking at theta prime, the adjacent side's right here. The hypotenuse is right there. So I'm going to go ahead and solve for the remaining side. A squared plus b squared equals c squared. And so let's find out what b is. Subtract 1 on both sides. 16 minus 1, I got 15. So b is the square root of 15. All right, so I got square root of 15 right there. That's my opposite side theta prime. So now I can do all my sine, cosine, and tangent now. Sine is opposite over hypotenuse, so that'll be square root of 15 over 4. Cosine is the adjacent over hypotenuse. Oh, they already gave us that one. That was the negative 1/4, right? Tangents, opposite over adjacent, root 15 over negative 1. So negative root 15. Cosecant, we can flip that over. 4 over root 15, but I got to rationalize that. So 4 root 15 over 15. Secant, we'll flip that one over. Instead of negative 1/4, negative 4 over 1. Cotangent, will flip that over. Instead of root 15 over negative 1, negative 1 over root 15, but I got to rationalize that. Negative root 15 over 15. And there's all 6 for that one. All right, this last one we've got, notice it's telling us where it's at. I'm less than pi, so I'm less than 180, but I'm greater than pi halves. I'm more than 90 degrees. So I'm somewhere in quadrant 2. That's my theta rotation, okay? So let's go ahead and draw this. Let's put our little theta prime in there, okay? And then let's use this information. They tell us the cosecant of theta is 3. Well, cosecant's 1 over the sine. Let me multiply both sides by sine and divide by 3. So the sine of theta is 1/3, right? If the cosecant of theta is 3 over 1, then the sine of theta would be 1/3. Well, that's my opposite side, and that's my hypotenuse using the reference angle. So here's the opposite side of theta prime. There's my hypotenuse, 3. So I just got to solve. I got to solve for b right there. So step 2, 1 squared plus b squared equals 3 squared. Subtract 1 on both sides. 9 minus 1, I got 8. B is the square root of 8. Well, and I know the square root of 4 is 2, so 2 root 2 is b. This is 2 root 2. Okay, now I got all 3 sides, and I can start working. My sine is opposite over hypotenuse, 1/3. Cosine, adjacent over hypotenuse, 2 root 2 over 3. Tangent, opposite over adjacent, 1 over 2 root 2. I do need to rationalize that. So my tangent actually ends up being root 2 over 2 times 2 is 4. Root 2 over 4 on that. Oh, shoot. I realize I just made an error. I'm so sorry, you guys. I'm in quadrant 2. Fix this. My x value is negative. When I go in the negative direction, I got to name this. All right, this is plus or minus. I got to name that a negative 2 root 2. I am so sorry about that. That's a negative 2 root 2 there. That'll change things. So that's negative, and that's negative. So sorry about that. There we go. Okay. So be careful when you're naming these, that you get them right. If you go into, for example, if you go into like quadrant, this one, right? And let's say you have this, and you have your hypotenuse. Make sure you name this negative whatever. right? Or into quadrant 4, you should have a positive, and then that should be a negative right there, and so on. Okay. All right, let's finish out the rest of these. They already gave us the cosecant 3/1. The secant here would be, I just flip this over, -3/2√2. I do need to rationalize that. So -3√2/4. And then finally the cotangent of theta would be 2√2/1. Anyway, circle all these. And there you go. Thanks so much for watching. Sorry about that error there. We'll see you guys next time.